Okay, so creating Debian-based embedded systems using Debos. My name's Chris and I'm an engineer at Collabora. I work on creating custom distributions for our clients. Usually these custom distros end up running on embedded platforms, embedded little boards that customers have bought, like Raspberry Pis, those sorts of development boards. But sometimes they end up on customer-specific hardware. Occasionally they end up running in the cloud on a virtual machine. So really, the images that I create end up running kind of everywhere, really. I work on continuous integration and packaging of the customer software. So basically, customers normally don't care so much about packaging their software. They just want their software to work. So we take the hassle out of that and package the software for them. We make sure that their devices can be upgraded over the air. We also implement fail-safes so that if the over-the-air upgrade fails, the power's taken out of the power jack or the internet connection's gone. We mitigate these sort of problems. So also I work on the tooling to make all of these things happen. So most recently I've been working on Debos and Fake Machine. So hopefully this presentation is going to give you a little bit of insight on what I've been working on over the past year or so. I'm also learning some Rust, which is proven to be quite useful for some of my daily tasks. Small scripts I've been writing in Python and Go in the past are now being written in Rust. Slowly but surely I'm getting there and the future is bright. So today I'm going to talk to you about what actually Debos is and how it compares to other tools. I'm also going to go through how to use it and the future plans that we've got for the tooling. Hopefully we'll get a chance for a question and answer session at the end, but please do download the slides and copy my email address. And feel free to email me if you have any questions that you feel weren't covered today. I'll do my best to get back to you. Also, I would suggest downloading the slides so you can get access to some of the blue links that I've dotted around the presentation. These should give you a little bit more context in places. So the link on this slide will show you the introduction to YAML, yet another markup language, which is extensively used throughout Debos, and also lots of other continuous integration systems like GitHub Actions, GitLab CI. These all use YAML, so I would highly recommend having a look. YAML is a fairly basic markup language. You should be able to follow along with the examples and get a feel for how the markup language works, but there are some details which the tutorial goes into quite well. So I'd recommend checking that link out. So first, I'd like to explain what a GNU Linux distribution is. In my opinion, it's a collection of software packages developed by like-minded developers. These packages follow a set of guidelines to meet this distribution. So all the packages end up working together quite well. You don't end up with too many breakages, hopefully, and the developers end up fixing bugs in the distribution and passing the bugs upstream and releasing new versions of the upstream software in the distribution. So each one of the distributions have different goals. So Debian is a distribution which uses apt for its package management and depackage. Red Hat use RPM and Yum for their package management. So there are lots of choices and design decisions which each distribution makes, and everyone has their own preference. I mean, my preference personally is Debian. I've been working with Debian since the 2000s, so I'm very familiar with Debian. But at the same time, I don't really know a lot about Red Hat or Fedora, so I would suggest asking someone else about Red Hat, Fedora, not me. But I think one thing that we can all agree on is the usual trend at the moment is for embedded targets to run a custom image generated by something like Yocturn or Buildroot rather than run a full distribution. Hopefully with tools like Debos we can change that and let distributions run on embedded targets. So why might you want to create your own distribution? So your project might have different targets. So your project might want to run on embedded board or multiple types of embedded board. It might want to run on a PC, or it might want to run in the cloud, or it may even want to run a combination of those. And usually you can buy, for instance, hardware development kits. These are supplied with a general purpose distribution that the developers have made for that development kit, and usually these are based on Debian or Ubuntu, and they're quite bad. I mean, they've got a lot of unnecessary, insecure and outdated packages, and they're incompatible with updating, and they've done a lot of hacks for that platform as well. So your own distribution would solve these issues quite nicely. From scratch, it's a lot of hard work to maintain a distribution. So my suggestion is there's no need to reinvent the wheel, and you should rebase or base your distribution on a proven technology like Debian. So Yocturn and Buildroot, usually the images are only for embedded platforms. I had our Yocturn expert shout at me last time I said this. No, you can run Yocturn images in the cloud now. But I would likely say that it's a lot harder than you need to have a lot of specific knowledge of how to run these images in the cloud. They create a nice custom distribution or a custom image, but it can become a maintenance nightmare when you want to update software or create packages for your own software. All the packages are compiled on your own machine, which some may say is a benefit, but I personally think it is a negative. Having to recompile a window manager every time I want to build a new image for different platforms is kind of not a benefit in my view. There's a high learning curve. So my suggestion is, why make things hard for yourself? My suggestion is to use Debian as a base for your image. So Debian is traditionally seen as a desktop operating system, but recent years a lot of effort has gone into enabling embedded targets and lots of different embedded targets. I think this mainly started with the Raspberry Pi. That really drove the embedded sort of world into some of the Debian developers. Debian was released in 1993 and it's widely used. And there are lots and lots of volunteers who shape Debian, inform Debian developers, Debian maintainers, and they follow a social contract called the Debian Free Software Guidelines, and they have a social contract as well, which basically means that all developers work to a common set of rules, and they're free to change these rules so long as the changes make sense. I think that's a great way of working. It's really community spirit. You're not being forced into doing things that you don't want to do by large corporations. It's all owned by the community. So I think that's really nice. These developers have written over 50,000 packages and libraries, and you can easily install or upgrade these using apt. The community is great. Unfortunately, these mailing lists, but if you're used to using mailing lists, then this is really not a problem. There are lots of tutorials on the internet, and it's fairly easy to get started. We have stable and testing distributions, as well as unstable, which have bleeding edge packages. Timely security updates go into the stable release, and unstable, or SID as it's known, usually gets the latest bleeding edge packages. And as I've already said, no one company leads the development or the direction of the project. The developers themselves lead the project, which in my view is very important. So using Debian as a base, in summary, lets you concentrate on the most important part of the project, your application. you haven't got to worry about the base operating system behind it and all the things that happen there. So some disadvantages with Debian. Debian only caters for systemd. This is changing. There are some changes in force to allow for other system managers, but I don't see this as a big disadvantage personally. Most of our projects use systemd and use systemd very well. The other thing is Debian packages are compiled with GitLab CI, so this can be a problem for very small embedded targets, but typically most projects now have got a fair amount of RAM and a fairly big CPU. I mean, it doesn't make a lot of sense in some cases to have anything smaller than a dual core sort of embedded processor, so I would suggest that these two disadvantages don't really matter so much these days. Debian was designed with desktop or server use in mind, but as I've said originally, it is coming onto embedded targets, but it needs a little bit more work than if you were to install it on the desktop. So if you're installing on the desktop, you can easily just plug in a USB with Debian installed on the USB and install that to your hard drive quite easily. With embedded platforms, typically you will run an image on an SD card. The Debian installer typically won't work for a custom distribution, so there's some challenges there, but Debos actually helps with installing the system on an image. So hopefully by the end of this talk you'll understand a little bit more about that. Debian are a little bit conservative in new technologies, but again, this isn't so bad. I think that this is quite a good thing to be conservative of new things, because sometimes new things aren't always good. There's limited enterprise support, but there is paid support by companies like Collabora to help customers with their projects. And Debian also has quite a slow release cycle, so stable upgrades happen every kind of 2 years, but that's not always a bad thing. And as I've already said, there are fresh packages in unstable, which suits most users. So how would you create a custom Debian image? So normally when you want to create a custom Debian image, you would create an image using DD. You'd basically flash the image with all zeros to begin with on your local hard drive. You'd insert a partition table using fdisk and format these partitions. You'd mount the partitions on a loop device, and then you can cheroot into the mounted image and debootstrap a basic Debian file system, install packages using apt, and then you can basically work on it as if it was a normal system on your hard drive by setting the host name, setting up user accounts, configuration files. And then at the end of all of that, you want to unmount the image, clean up the loop devices, compress your image, save the build logs, and then hopefully after that you've got a nice image. It's nice until the whole lot breaks, and also you have these problems where it works on your machine but it doesn't work in the continuous integration machine, or it doesn't work on other developers' machines. There are lots of issues with this kind of script-based setup. There are lots of tools out there already that follow this kind of routine. There's a presentation called The Many Methods to Build a Debian Image by Riku, which summarizes the most popular tools. Usually these other tools serve a very specific purpose. So originally, when I first started looking at Debian systems, I was looking at a tool called Spindle, which basically created Raspberry Pi images, but the images were very specific just for Raspberry Pi. So at the time I was looking at creating a BeagleBone Black image, and I couldn't create an image using Spindle for that without a lot of hacking. So these other tools also have random failures, which we call it. Debos is inherently a lot more robust against these failures, and it's also a lot more flexible than these other tools that serve very specific purposes. Debos generates your custom image from one configuration file, which can be stored in version control, which is quite nice. We also use GitLab continuous integration to build images as soon as they're pushed into the version control. I'm going to go into a little bit of that in this presentation as well. Collabora are constantly evolving and improving DebOS, and Partition, which is a project by Collabora and Bosch, is continuously evolving DebOS as well, because Partition use DebOS to generate the images for their boards, so that's very good. Basically, I think you're going to get started with DebOS quicker than some of these other tools as well. So the solution to all of these problems is DebOS. Basically, it uses a library called Fake Machine to create a virtual machine on your computer. Disks are attached to the virtual machine, so we don't use loop devices, and that's very good because these are loop devices, as we've discussed, are very fragile. We have a recipe file which contains actions or the steps to create your image, and these recipes are translated into commands which are run inside the VM in this clean environment, and the recipe actions abstract the changes and the configuration files and the commands, so basically you don't have to write so many commands in your build script. When there's no action already created, you can just run a shell command or a script inside the fake machine, which then you can change route into the disk image and do any changes you want there. Easy cleanup. If anything goes wrong, you just kill the virtual machine. And this is quite nice because it doesn't break your host. Everything's reproducible on your computer as well as in the CI system, which all of these things I think make DebOS quite a nice solution for building your own images. So you've got lots of people using DebOS. We've got Partition, Kernel CI, Redaxer, the Mobium project, Plasma Mobile, Gemian, and also reproducible builds use DebOS. This is just a short list here. I'm not going to go into detail of all of them because I don't think I've got the time today. But please feel free to check these projects out. They're very cool projects. So DebOS is a tool written in Go. You don't need to know Go to run DebOS. You only need to know Go if you want to add features to DebOS. There is Fake Machine, which is a separate library and a standalone tool which Collabora have generated, which creates virtual machines. Packages for both Fake Machine and DebOS are in Debian stable. We try to update these packages fairly quickly as well when new features are added. It's also available as a Docker container, so you can run it pretty much anywhere. We use a Docker container to run in the GitLab continuous integration, and also you can install from source on other operating systems fairly easily too. So Debos Recipe is a YAML file which defines the steps to create your image. As we've said already, it's simple and can be version controlled, and the recipe consists of a header which has got the metadata, for instance the image architecture, and an array of actions which are ran sequentially. Each of these actions has their own properties. So the YAML file has comments inside of it, or you can add comments if you so wish. I'd highly recommend adding comments to all code that you write. For me, my memory's like a sieve, so if I don't write comments in 3 weeks' time, I won't know what the point of the comment of the code was. All of the recipes are pre-processed through the Go templating engine, which allows you to have variables, if-else statements, and you can also include recipes in other recipes, which is all very nice. So enough talk. Here's a simple example. Again, please copy these slides and copy the example. This example, as the comment says, creates a tarball of a simple Debian operating system. So basically, you can run this on Debian using the steps I've given here. You basically want to install Docker first and then run the Docker container, and then you get this output here of each action inside the recipe, and at the end you get a tarball with the contents of a operating system. So here again I've shown you the original recipe on the left hand side and the output on the right hand side. you can see how each action relates to some commands. I've had to remove the command output because it doesn't actually fit on the screen, but hopefully that gives you a quick overview of how the actions relate to the output. You can also run this in GitLab CI using the Docker image. So as you can see here, it's not much, it's about 12 lines of code to actually run this in GitLab CI. And GitLab CI is very helpful because it shows you whether things pass or fail in the browser. Everyone on your team can see it. You can set jobs up to run on a schedule, so nightly. You can have email notifications when things don't work. It's all very nice. So then Debos has a bunch of actions which you can use to create your operating system. So we've got the debootstrap action, which sets a basic Debian system up in the file system. We've got the apt action, which installs packages. We've got the pack and unpack action, which pack and unpack tarbles. Image partition uses some tools on the operating system to create an image partition table, format file systems. And it's very comprehensive, the partition layouts that you can create with this tool. I actually, as a tip, use Debos recipes, even not when creating Debian systems. So it's very flexible in that regard. You can use Debos to generate a system or an image which contains virtually anything in it. We've got file system deploy, which actually copies root file systems from a temporary directory into an image. We've got overlay, which copies files from your host machine into the container and inside the target file system. We've got the raw action, which writes images to a partition. So you can write things like bootloaders or pre-prepared images. So I use the raw action as a tip to copy vendor-provided root file systems into an image and then modify the image that they've given. The run action allows you to run scripts or commands inside the virtual machine or inside the actual image that you're creating. Then here is an example of variables. So you can define variables and you can use the variables inside the recipe. You can pass the values to these variables on the command line, and you can also do things like printf. There's an example there where we generate the file name based on two other variables, so that's quite nice. You've also got some defaults at the top, so the default of those two values. Also, the scripting allows you to do if-else, so you can pass in this example here, you can install different packages based on what architecture you're running, which is quite useful. You can also run recipes inside recipes using the recipe action. You can also pass variables into these other actions, and the variables from the command line is also passed in. So that allows you to abstract reusable things into a different action, into a different recipe, which is quite nice. We've got some more examples here. We've got a recent Raspberry Pi image, which one of my colleagues, Dennis, has created. That's a very basic image, which just bootstraps a basic Debian image onto an SD card for you to run. Also, we have Apertis, which is, as I've already said, the automotive operating system by Collabora. These recipes have got more scripting in them and if statements. There's an OS pack image, which basically includes everything to create the operating system. And then on top of that, Apertis have a kind of hardware pack, if you like, which allows you to create Raspberry Pi image, this example, but there are other example images for other targets as well. So the future plans we've got for Debos, some of these actually are already finished. By the end of this year, we wanted to have Raspberry Pi 4 example recipe, which we've now got. We wanted, instead of fake machine just running under KVM for a virtual machine, we wanted to add user mode Linux. So We could build images without KVM, and this works quite nicely. So you can build images inside things like GitHub Actions or inside cloud workers that don't have access to which don't have access to KVM. This is quite useful because by default most cloud images or cloud providers don't allow you access to run nested virtualization. We want to have some more useful actions, so you want to be able to install a Debian package from a file, for instance. We want to have automated testing in place so that every kind of push to Debos doesn't break any recipes or break any customer projects, really. And next year we'd like to add some support for Arch Linux, so basically running Debos on Arch Linux. We'd like to create some more recipe examples, some documentation and some blog posts around the changes we've done to Debos, so hopefully we can market the sort of products or the free open source technology to others who may not know about it. We'd also like to have automated recipe builds. The example recipes I've already mentioned, building automatically on GitHub Actions. And if all of that goes to plan, we'd like to release version 1.1. So thank you, and I'll take any questions. Again, if you didn't manage to ask any questions on the chat here, please do feel free to email me, and hopefully we'll see each other again soon.